Hey math kids, today we're going to talk about get an introduction to an integral. And what an integral is the way that we find the area under a curve. And so the first thing they want us to do, they want us to draw this function from 0 to 1. And then they want us to shade in the region that we'd be finding. And so x to the fourth looks a lot like x to x squared, but the slope goes up a little bit different. And so this is from 1, this is from 0, and so we shade in everything between the x-axis and the curve itself. Now, the next part, part B, asks us to use upper and lower rectangles to find the area, and you're not going to do it that way in real life, and you can do it a quick way on your calculator. However, I'm not going to teach you the way to do it the quick way on your calculator. I'm going to go through the slower way, and I'm only going to do it for n equals 5, which means how many rectangles we actually use, which would be 5 rectangles, because I think having a conceptual understanding is important. But if you're going to use a calculator to do this, you might as well do it the real way. And later in the class, we'll learn the real way to do this on a calculator. So I can't think of a situation where you would ever do this way, other than to try to understand it conceptually. So that's why I'm doing it kind of the long way, and I'm only going to 5. So what you do is you split 0 to 1 into 5 equal parts. So it's going to be 0.2, 0.4, 0.6, 0.8, and then up to 1. And all I did was I took, for my lower, so my lower rectangle is right there. So that's at 0. I plug in 0 to x to the fourth, and I get 0. Then I plug in 0.2 to get the height of that one, and I get 0.0016. Then I plug in 0.4 right here again. Then I plug in 0.6. Then I plug in 0.8, and I get all of those heights. Then for my upper, I just flip it around. This time it goes this way, so the height is 0.2. Notice how it's the same there. Then the height is, and it goes on until I get to that last one where the height is 1, because if I plug in 1 right here, I get 1 to the fourth. So that's what all these heights are. Now, I'm going to find the actual area by taking each of these numbers and multiplying it by the width, which they all have the same width. So if I just multiply each of these by 0.2, I'll get the numbers that I want. So 0 times 0.2 is 0. If I get 0.0016 times 2, no, not times 2, times 0.2, so that's 3.2 e negative 4. So what that means, it's 3.2 times 10 to the negative 4. So we need some zeros right here. We go 1, 2, 3, 4. So we get 0.00032, and that would be right here too. All right. Now we try 0.2 times 0.0256. We get 0.00512. 0.00512, 0.00512, and we're going to just keep going with this. Point 0.02592, 2592. What was that? 2592. Okay, keep going with it. 0.4096 times 0.2, 0.08192. 8192. 0.08192. 0.08192. And then if we do 1 times 0.2, we just get 0.2. Okay, now we just need to sum. We don't care about this sum or this sum, doesn't really matter. We just add the blue ones. And so we're going to get 0.00032 plus 0.00512 plus 0.02592 plus 0.08192. We'll get 0.11328. And down here, we would just add 0.2 to that. So it's going to be 0.31328. And if we wanted to find a little bit better estimate for that, we would do 0.11328 plus 0.31328. Divide that by 2. We're just averaging those two. And so we already have that one on the screen. So we add 0.31328 and then divide by 2. We end up with 21328. So that is a pretty good estimate for the area under this curve, or the white section. Okay, so that's essentially what an integral is doing. And then the last part on this, it wants us to evaluate from 0 to 1, x to the 4th dx to two significant figures. So we already found that, and so we look at this, and two significant figures is going to give us 0.21. Okay? I think that's it for this video. No, we actually have another problem. So let's keep going. Okay, it says use graphical evidence and known area facts to find this. So we're still not doing like the calculus part yet, but we're still looking at this in a pretty conceptual way. And the better you understand this conceptually, the easier it will be in the future when we're using this. Okay, so what we're going to do is we're actually just going to graph this. And so we start at 1. It's just a line, so 2x plus 1. And then we go up 2 over 1. Okay. And then we want to go even more, so we go up 2 more over 1. So we have this. And we're going to go from 0 to 2. And so the area we're looking at is this. Now I'm going to look at it as a rectangle with a triangle on top, specifically a right triangle. Okay, so the area of the rectangle, it's 2 by 1. So area of the rectangle is 2 times 1, so that's 2. Now the area of the triangle, well, the height is 1, 2, 3, 4, and the base is 2. So we get, area of triangle, we get 1/2 base times height. The 2 and the 1/2 cancel because half of 2 is just 1, and so the area of the triangle is just 4. Okay, so we have these two pieces, so the area of the entire thing is 4 plus 2, or just 6. Okay, now we're going to do this. If you need to, graph this on graph this using Desmos or your graphing calculator to see what this looks like. But it's actually just a semicircle. Okay. So what it looks like, it goes from there to there, where this is 1, this is -1, and this is +1. And we want to find the area just from 0 to 1, so we actually only care about this portion. Okay, so what we're going to do is we're just going to find the area of an entire circle and then divide it by 4, because we just have a quarter circle. So area of a circle is pi r squared. The radius on this one is 1. And so the answer is just pi, but that would be for the entire circle. And so we divide our answer by 4, and then our final answer is pi over 4. If you need additional help, please come to Math Lab. Until then, calculator.